Hi, my name is Srinath. I'm the Chief Engineer of the UCI Rocket Project. Today I'm going to go over what we do here at the Rocket Project and what we've done this quarter in terms of progress. So we're one of over 30 undergraduate teams pursuing liquid bipropellant rocketry here in the United States. So we do this in order to foster interest in the aerospace industry, and we're also competing in Friend of Amateur Rocketry's $1 per foot challenge, where we're trying to launch a rocket to 45,000 feet. So our main goal for this year is to launch Peter, our preliminary test rocket. So in order to pursue that, we've conducted our first successful static test fire of our PD engine, and later on this year we're going to conduct more static test fires to fully characterize our engine, and then conduct a vertical test fire to test our flight configuration before actually building the rocket and launching it in the air. So this is a basic timeline of what we're going to do, and as you can see, it covers all the static test fires that we're going to do this quarter out in the desert, our manufacturing processes, and our final launch in the spring quarter. So our team is broken down into 4 main sub-teams, 3 technical sub-teams, which include propulsion, which is in charge of testing and designing our various engines and our fluid system. Our avionics sub-team in charge of creating our flight controller, our instrumentation, our data logging, telemetry, and basically everything electronics related to collecting data about our engine, controlling our flight vehicle, and analyzing any data we need. And finally, our launch vehicle sub-team, which is in charge of basically creating the actual vehicle structure that we can put the propulsion system in and launch in the air. Our operations sub-team isn't completely technical, but it's as crucial as the rest. We're in charge of data management, documentation, organization, purchasing, finance, anything that makes a project actually run. So towards our static test fire, we've conducted a lot of different tests. So the first one we conducted last spring was our first water flow test, just to basically verify the manufacturing of an injector, which we conducted back behind Engineering Gateway. As you can see, our injector was manufactured pretty well using EDM, electrode discharge machining, to create pretty precise holes for fuel injection. Then in the middle of the fall quarter, we conducted various cryo tests. This is a pretty good example of one of them. Running liquid nitrogen through our whole system and through our chamber. This particular test had a failure between the chamber and injector, which caused a leak of liquid nitrogen, and which we eventually fixed with new O-rings. And then this is the last test we conducted before our attack test fire, basically verifying our ignition system with all the timing and making sure all the circuitry worked well. So right here is our ignition system. That's beautiful timing. And then there's a delay before it finally turns on. During the actual test fire, this ignition system would be implemented inside the chamber, and once the propellants flow, it would ignite and fire, which you'll see in the final video. There's the ignition system, and if you look at the reflection, you can see our Mach diamonds, which are beautiful. So we were able to conduct a successful 3-second test fire of our engine, which produced really steady results. And we want to conduct further testing on our engine for the full duration of the fire, and with an improved test stand, improved instrumentation, to get all the data we need and to create a more, robust system that's easier to test, easier to put together, easier to clean, things like that.